looking at the position vector and the displacement vectors in the previous class. Right, we'll continue from there. Let us try to solve a problem. Okay, this is a problem. A force F has magnitude of 15 Newton and it is located at 37 degrees from the negative x-axis. X-axis in the second quadrant. Okay, fine. Its equation. What is the equation of this? In a sense, we need to write a vector representation for this. Okay, so let us try to draw and analyze what exactly has been given. Alright, so let's say so there is a vector. That vector is 15 in magnitude and mix. So this is 1, 5. They mentioned that this is 15. Okay, and it actually makes 37 degrees with respect to the negative x-axis. So this is positive x and the other side is negative x. That's why we are writing it over there. This is the positive y. So negative y comes below. Okay, and now since it is given that the orientation of the required force is like this and it makes the angle, certain angle with respect to the x-axis, we can definitely find out what is its x component and what is the y component. Alright, so let us try to write. So this is the actual force F, and we are supposed to find out what is the Fy and what is the Fx first. So we know the basics, right, and we can write that since the angle is given with respect to x-axis, we can write the Fx. Fx is equal to F cos theta. So that is 15 cos 37 degrees. Okay, the 15 cos 37 comes to be 12. So 12 Newton is along x-axis. Okay, and Fy can be calculated as F into sine theta. So this is 15 sine, and since it is negative, sorry, I think I missed the sign convention, sorry, please consider that. This is minus 15, minus 12 Newton, right, because the convention says it is along negative x-axis, so it is minus. Okay, so Fy is positive, right, so this is 15 sine 37, and since it is a positive quantity, we can directly write this is equal to 9 Newton. 15 sine 37 is 9, right? So now I know that I have to give a vector notation in terms of I and j. Whatever is along x-axis, it gets multiplied by a unit vector I, and whatever is there along y-axis will get multiplied by a component, that is j. So therefore the f vector can be represented as x component is minus 12 into I cap and y component is 9 into j cap. Okay, so this is the required answer, and again definitely you can give the unit as Newton because this force is a representation, this vector is a representation of the force, right? That's why you can give a notation, that is, you can give unit as Newton. Right. Let's move to the next question. The question is resolve a weight of 10 newtons in 2 directions. Which are parallel and perpendicular to a slope at 30 degrees to the horizontal. Okay, so this is our target. So let's try to understand the question first. Right. So it says that there is a slope of 30 degrees with the horizontal. This is the first line to be considered in this problem. So let us draw the horizontal first and then let us draw the inclined plane. So this is a horizontal. Say this is the actual the ground plane. On this we have a 30-degree inclined plane like this. Let me rewrite. So this is the inclined plane and I consider this to be 30 degrees. This is the given data. Okay, on this, right, on this particular inclined plane, you are applying a weight of 10 Newton. So remember, always the weight acts perpendicular to the horizontal. It's not going to act perpendicular to the plane where it is standing. In the sense, let us say that there is a person standing here. Okay, if a person stands here, right, his weight is not in this direction, but it is always in this direction. Okay, so that's the difference. So weight of 10 Newton. So weight means it's the weight of maybe a ball standing over there. So it means whatever that I'm going to draw will be perpendicular to the horizontal surface, not to the inclined plane. So I will draw in this fashion. So you see this particular weight, you see it is actually perpendicular to the horizontal axis, right? It is actually perpendicular over here. This is 90 degrees. So this weight, this W is equal to 10 Newton. So now the question is that resolve this 10 Newton into 2 directions, parallel and perpendicular to the slope. So the question now is simple. So resolve this 10 Newton into a component that is along this direction. This is parallel to the slope. Okay, so I can write this as WP for W parallel. And also I want one more component that is perpendicular to the slope. Okay, so I can write this as, let's write another one another force here. Let me write it perpendicular. Perpendicular. So you see this is actually perpendicular. Or even on the other side I can write. Perpendicular component can be anywhere. Okay. So this is what I'm going to call as WP. W parallel is already written, and I'll write W perpendicular, that's W normal. Okay, WN for W normal. So here this is 90 degree. So what is WP and what is WN is a question. Okay, we just have to find these two components according to this. Alright, now I need to identify different angles. Correct? So W is acting here, right? If this is 90 degree, this is 30, this should be 60. This is 60, this is 90, so this has to be 30. So W makes an angle of 30 degree with the WN. So you see WN can be calculated in a straightforward fashion. So WN is equal to, see, angle is given with respect to WN itself. So this has to be a cos function. So this is W cos 30. So that is 15 into cos 30 degrees. 15, 10, right? Sorry, minus 10. So this is 10 into cos 30. I think that comes to be 10 by 2, 5 into root 3 by 2. So 5 root 3 newtons. Okay. Similarly, we can calculate the WP, which is the parallel component, horizontal component. This has to be, you see, angle is given with respect to the other side, so this has to be sine. Okay, so W sine 30. So this is 10 sine 30. So 10 sine 30 is 10 into half. So this is 5 Newton. Very straightforward answer. We'll come back to various problems in a different stage at the end. Okay, once we discuss all concepts, we'll come back. So let's move on to the next topic. This is the product of two vectors. So when we want to perform the product, when we want to multiply two vectors, we can do in two ways. The first technique is called as the scalar. Scalar product, it's also called as the dot product. Alright, so again we use a specific convention here. Let us assume that we have two vectors like this. Say if one is vector A, one is vector B, and there's an angle theta between the two vectors. So dot product of two vectors is denoted as vector A dot vector B. This can be easily calculated as vector A into vector B into cos of the angle theta between them. Okay, and this product, the scalar or the dot product, is always a scalar quantity. In a sense, when I multiply two vectors using the scalar product, the answer is scalar, it's not a vector. Okay, that's the important point to be remembered. Alright, then let's say let vector A is denoted by say A1 into I cap plus A2 into J cap plus A3 into K cap. It is a three-dimensional representation of the vector. Okay, x, y, z coordinates. X coordinate has a unit vector I cap, y coordinate has a unit vector j cap, and the z axis has a unit vector k cap. Using that we write. Similarly, let's write the b as well. So this means vector b is given by b1 into I cap plus b2 j cap plus b3 into k cap. If the vector notations of both vectors have been given in this format, then we can write the vector A dot vector B is equal to, it's actually written as A1 I cap plus A2 j cap plus A3 k cap dot B1 I cap plus B2 j cap plus B3 k cap. So this answer is nothing but I multiply only the terms containing I and I together, j and j together, and k with k. That's my actual answer. I have to put a sum in the middle. That's why it is A1 B1 plus A2 B2 plus A3 B3 is the answer. You see, there is no I, j, k with this answer. That's why we told that the answer is a scalar and it's not a vector. Okay, you guys, next let's move further. Now we'll try to write some of the important points related to the dot product. Okay, we can take it as a note. Now the first point is that if you perform vector A dot vector B is same as vector B dot vector A, dot product, right, satisfies this condition. And the second one is that if you are taking a dot product of A with B plus C, this is same as A dot B plus A dot C. Yeah, we use the vector notation for everything because indication of them to be vectors is important for us. So it's vector A dot vector B plus vector A dot vector C. Now we'll come to the dot product of unit vectors first. Okay, let's try to write I cap dot I cap because I is actually a vector, right? So I can definitely take a dot product. So I dot I means this is, what's the magnitude of I? It's 1. What is the magnitude of I? It's 1. So 1 into 1 into cos theta. What is the angle between I and I? It is 0, right? Because if this is I cap has a magnitude of 1. So let's go back to the equation for a moment. Equation says A dot B is magnitude of A, magnitude of B into the angle between them, take a cosine value. So I dot I has to be 1 into cos 0. So cos 0 is 1, so the I dot I is 1. So this actually implies even J dot J cap equal to K cap dot K cap is also equal to 1. Important thing, so I dot I, J dot J or K dot K is going to generate 1 as an answer when you take a dot product. Okay. Then let us calculate the other options, that is I dot J. So what is I? Magnitude is 1 into what is magnitude of J? That is also 1. Okay, but what is the angle between I and J? If you look at the angle between I and J, I is along x-axis, J is along y-axis, correct? So I and J, they have an angle of 90 degree between them. So this is cos 90. Cos 90 is 0, right? So one term is 0. So 0 into 1, answer is 0. This is true for even the other options. Like I dot K is also 0. That is same as J dot K. So when I take a dot product of same vectors, you have an answer to be equal to 1. And whenever you take a dot product of any two mutually perpendicular vectors, answer is 0. So from this we come to a conclusion. This is also a note. For perpendicular vectors, in the sense if vector A and B are perpendicular, we know that their dot product is equal to 0. So this implies their dot product is equal to 0. So if a question comes that check that whether the two vectors are parallel or not parallel, sorry, perpendicular or not, right? So simply we can take a dot product to find out the result. If it is 0, we can say yes, they are perpendicular, otherwise they are not perpendicular. So we cannot say that whether they are parallel in this case. And so using a dot product, we can do all these things, and we can try to answer the questions related to any of them. Okay, then let's go to the next concept. That is, let's try to calculate the angle between the two vectors. Okay, so two vectors A and B are given. So we know that vector A dot vector B is nothing but AB into cos theta. So this implies I can actually calculate the cos of the angle theta as the vector A dot vector B divided by their product of the magnitude, that is A into B. So how do you calculate theta between those two vectors? It is cos inverse of vector A dot vector B whole divided by the product of their magnitudes. This is one very important equation which we are going to use many times. A force, that is F vector, given by 2i cap plus 3j cap plus 4 into k cap newtons acts on a body and displaces it from its location pointed by a position vector R1 equal to 2i cap plus 3j cap plus k cap 2 to the point pointed by another position vector, that is vector R2 is equal to, this is I plus j plus k newtons. Okay, the question is find the work done by the force. So if using the vector notation, the work done is equal to force dot the displacement. It's a dot product of two vectors. Force is a vector and displacement is also a vector. By mathematical notation, work is equal to force into distance or displacement. But in the vector notation, it is a dot product. And the work done is not a vector, it is a scalar. So when you take two products of vectors and answer is a scalar, it has to be a dot product. Okay, so now I need to first, F is directly given. You can see that F is given over there. But the displacement is not given. They have given the position vectors. So it actually starts from R1 and it goes to R2. So the S vector is nothing but, right, use the concept of displacement to get the position vector, right? So, position vectors to get the displacement. Sorry, my mistake. It should be the reverse. So let's use that. So S vector, it's a displacement, is equal to destination, which is R2 minus R1. So R2 is given. R2 is nothing but I plus J plus K. This is R2 minus R1. So this is 2I plus 3J plus K. So normally we do the subtractions term by term. Whatever is there with I can subtract. So 1I minus 2I is minus I. So this is minus I cap. Then I am performing plus J minus 3J is minus 2J. Then K minus K is 0. So this is the position vector of the displacement. So displacement is measured in meters. You can write the unit as meters. So simply calculate W is equal to the force dot S. So force is given. You can see that the force is given as 2I plus 3J plus 4K dot of minus I minus 2J plus 0K. So let's go back and check how to multiply using this. So we have the product like this. So simply multiply the terms containing I and I together, J and J together, K and K together, and add them to get the final result. Okay, that's the way to calculate the dot product. So therefore this is equal to, so 2 into minus 1 is minus 2 plus 3 into minus 2 is minus 6. And the last term is 0, 4 into 0 is 0. So the answer is minus 8. Since it is the work done, it is joules. See, the answer is a scalar quantity. Okay. Next question. Find the angle between the vectors A and vector B. If vector A is equal to, this is 2I cap plus J cap minus K cap, and vector B is given by I cap minus K cap. Okay, so I know that the equation for the product for the angle theta is equal to, this is cos inverse of vector A dot vector B divided by magnitude of A into magnitude of B. Right, so I need to the dot product first. So let's calculate the dot product. Vector A dot vector B has to be, right, 2I plus J cap minus K cap dot, this is I cap minus K cap. So this means I can get the product directly. So that is equal to 2 into 1, that is 2. Then there is no J in the second term, so 0. And the last term is minus 1 into minus 1, that is plus 1. So the dot product of the two vectors is, it gives 3. Alright, so that's the first part. And now let's calculate the magnitude of A, right? So magnitude of vector A is equal to, we know how to calculate the magnitude. It is square root of every component square, 2 square, 4, plus 1 square, plus minus 1 square, which is 1. Okay, 4, 5, 6. So this is root 6. So similarly calculate the magnitude B, right? So magnitude B is under root, so 1 square plus minus 1 square, so this is root 2. So this means theta should be equal to cos inverse of, substitute, A dot B is 3 divided by, this is root 6 into root 2. Okay, so this is cos inverse of 3 divided by root 12. Okay, this is 4 into 3, 4, root 4 is 2. Okay, this is cos inverse of root of 3 by 2, root 3 by 2, which angle has a cos ratio root 3 by 2? It is 30 degrees. So theta angle is 30 degrees. So question remains same. Find the angle between the two vectors. This is minus I plus 7j plus 6k, and vector b is equal to 3i cap minus j cap plus 4k cap. Okay, please calculate and give me the answer. What is theta? Cos inverse of 0.29. Okay, that's correct answer. Right, I'll ask another question now. So this is, show that vector A is equal to, this is 2i minus 3j plus k cap, and vector B is equal to I cap plus j cap plus k cap. Show that these two vectors are mutually perpendicular. So what you have to prove? You have to show that the dot product is equal to 0. Simply calculate the vector A dot vector B. See, this is 2 into 1 is 2. Minus 3 into 1 is minus 3. Plus 1 into 1 is this. So 3 cancel like 0. So since the dot product is 0, you can say that both the vectors are perpendicular to each other. Then we'll move on to the second type of the product. This product is called as cross product. Of two vectors. Okay, so this is represented as vector A. Cross product is a x, right? Previously it was a dot, now it is x. A vector x, B vector is actually vector A into vector B, both magnitude into the sine of the angle between those two into a unit vector n cap, right? So A, B are fine for us. Theta is also fine for us. Now let us look at what is this n cap. Okay, so let me draw something before we understand what we are looking for. Okay, let us consider a scenario. Let us consider a plane first. Let's say we have a plane like this. Okay, and on this plane we have two vectors. First vector is this. Say this is vector B, and I have another vector that is, say, vector A. This is also on the same plane. That's why it's like this. And there is an angle between the two vectors, which is nothing but theta. Okay. Now I want to take a cross product. So vector A into vector A cross vector B is nothing but A is magnitude. Multiply that with the magnitude of vector B, and then multiply with the sine of that angle theta, right? And I need to multiply by a vector, that is n cap, which is a unit vector. Since there is a cap, it means it is a unit vector. Okay, so let's see what is this n cap, right? So n cap is this vector. So I'll try to mark a perpendicular line. So this is the direction of the vector A cross vector B. The product comes in a direction which is perpendicular to both A and B. Okay, and the unit vector along that direction is n cap. Right, so this is a scalar quantity. Scalar into vector becomes this vector. That's why, right, you see it is there is actually a thumb rule. The direction of A cross B is, right, the direction where the thumb, our right hand thumb is going to mark whenever I move the curl from A to B. Okay, curl of my hand when I move from A to B, what is the direction in which my right hand thumb points out is the direction. So you can see that if I try to hold the right hand thumb in such a way that the curl, all other fingers are pointing in A to B direction. So A to B is this direction. This is A towards B. Then the right hand thumb points upwards. That's why A cross B is upwards. So this is what is the rule called the thumb rule of cross product. Right? This is helpful in finding out which is the direction of the result. A cross B comes in which direction, we can find out using this. Alright, so let me write what is n cap. So n cap is a unit vector perpendicular to both vector A and vector B. So this is how we calculate the cross product. All right. Now let us see how to calculate. So we can calculate them easily by using the following convention. Let's say vector A is equal to A1 I cap plus A2 J cap plus A3 into K cap. Similarly, let's assume that the vector B is denoted by B1 into I cap plus B2 J cap plus B3 into K cap. If this is the case, I can calculate the vector A cross vector B by solving a determinant, that is I, J, K. First you write the second first row of this determinant is always I, J and K, and below that what we are going to write will be the first component. If it is A, I have to write the components of A. That is, what are the components of A? We know that components of A are A1, A2 and A3. And next I am going to write B1, B2 and B3. Solve this determinant, you get the answer of A cross B. Okay, that's the first idea. So this is how we can calculate A cross B. Now we know something already about that. Okay, we'll start with the note. These notes are important to solve the various problems associated with the cross products. So we know something about the cross product, that is vector A cross vector B has to be equal to AB sine theta into n cap. So this means if you want to calculate the magnitude of A cross B, this has to be simply AB sine theta. Because AB sine theta is a magnitude, n cap is the direction. So how to calculate the sine theta then? So this implies the sine theta can be easily calculated as magnitude of vector A cross vector B whole divided by AB. So this means if you want to calculate the theta using sine ratio, then this is the formula. Sine inverse of magnitude of vector A cross vector B whole divided by A. Okay, then the next point is, if you take a cross product of vector A cross vector B, this is always negative of vector B cross vector A, because when I perform B cross A, my right hand curl will point from B to A, so that the thumb is going to point downwards now. So downwards is actually opposite of the previous direction, which was upwards, so you have a sign change. This is minus B. Minus of the previous answer, minus of B cross A. This is the next point. So A cross B is not same as B cross A, it's minus of B cross A. Okay, then let's try to take the cross product of I. So let's say I cap cross I cap. So you see I cap cross I cap is nothing, right? 1 into 1 into sine 0. Sine 0 is 0, so this is 0, right? So it means the J cross J is also same as K cross K, that is also 0. Okay. Then moving to the next point in this note, our intention here is to take the cross product of two different vectors. Like I want to perform I cross J, right? So I cross J is nothing but, what is I? It's 1 into J is also 1 into, see the angle between them is 90 degrees, so this is sine 90. Now it's non-zero, so I have to multiply by a vector which is perpendicular to both of them, right? So if I say this is my x-axis, so this is I, and this is the vector, this is J. Now when you perform I cross J, you should write a vector along this direction, which is k cap. So it is k cap. So this is 1 into 1 into 1 into k cap. So the point is I cross J is equal to k cap. Similarly, now you can verify J cross K is equal to I cap, and the K cross I is J cap. These are the other two equations. So how to remember? This is easy to remember. Write them in the clockwise direction. So this is I, this is J, and this is K cap. Okay, so if you move I, this is positive. Okay, I cross J is positive. So the answer is the opposite one. I cross J is K. Alright, then you do the reverse. J cross K, this is also positive. So answer is I. And K cross I, when you move, assume that the clockwise movement is considered to be positive. So I'll write a plus here. Okay, inside that I'll write a plus, indicating that when I perform K cross I, right, in clockwise direction, it's considered to be positive. So there is another version that is negative, right? I'll write J and K, but you see I am moving in the opposite direction. This is negative. Answer is negative now. That means if I perform I cross K is minus J. Okay, because this is anti-clockwise. So anti-clockwise is considered to be negative for us. So even if you do in the same fashion, we can get the answer by using three vectors which are mutually perpendicular to each other, which are plotted on a graph, and we can find this. So this also implies that I'll perform K cross J. K cross J is minus I cap. Okay, and I'll perform J cross I. J cross I is minus K cap. So these are the 3 required answers.